This video will cover Graham's law of effusion. Graham's law says that a gas will effuse at a rate that is inversely proportional to the square root of its molecular mass. As we look at this mathematically, what we have is the rate of chemical 1 divided by the rate of chemical 2 will equal the square root of the molecular mass of chemical 2 divided by the molecular mass of chemical 1. So what exactly does Graham's law allow us to calculate? Well, let's look at an example. Under the same conditions of temperature and pressure, how many times faster would hydrogen effuse compared to carbon dioxide? Well, if we look at it and we use the formula that we mentioned, we take the square root of the molecular mass of carbon dioxide, this is the weight from the periodic table of CO2, and we divide that by the molecular mass of hydrogen. Now remember that hydrogen is diatomic, and therefore we have the molecular mass of 2. When we do the mathematics, we get 4.69, meaning hydrogen will effuse 4.69 times faster than carbon dioxide. So let's take this problem one step further on the next slide. Here we have the same problem, adding just a little bit more information. If carbon dioxide takes 32 seconds to effuse, how long would it take hydrogen to effuse? Well, we take the 32 seconds that it would take for carbon dioxide, we divide it by the effusion rate that we had calculated on the previous slide, and we would see that it would take hydrogen 6.82 seconds to effuse. Let's look at one more example of Graham's law. An unknown gas diffuses at 0.25 times as fast as helium. What is the molecular mass of this unknown gas? Again, we're going to use the same formula that we had used previously. Here, we would have 0.25 as our rate of 1 over rate of 2. We'd calculated that. We take the square root. We know that the molecular mass of helium would be 4, and again, helium is diatomic. However, in this problem, we do not know the molecular mass of our unknown gas. We simplify our equation, and so we get 0.25x equals 4. We solve for x, and we remember that we must square 8 in order to account for our square root of the problem. And we would have 64 grams as the molecular mass of our unknown gas.